and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the solution process. In our last lesson, we learned about mixtures, including those that are homogeneous and those that are heterogeneous. We also discussed the difference between solutes and solvents, and suspensions and colloids. In today's lesson, we will learn about the like dissolves like rule. We will discuss how this rule depends on interparticle forces of attraction, and we will explain how it can be used to predict relative solubility. When a solute dissolves in a solvent, the particles of the solute disperse throughout the solvent. The solute particles take positions that were previously occupied by the solvent molecules. In other words, the particles mix together. The relative strengths of three types of interaction affect this tendency to mix. These types of interaction include solvent-solvent interaction, solute-solute interaction, and solvent-solute interaction. There are strong forces of attraction between solute particles and other solute particles, and solvent particles and other solvent particles. These strong forces keep the particles close together. This reduces solubility of a solute in a solvent. There are also strong forces of attraction between solute and solvent particles. This makes for easy solubility and helps to keep particles in solution rather than settling. The solution process can be shown in 3 steps. First, the solvent molecules separate from one another to make room for the solute particles. Then, the solute molecules separate so they can merge into the solvent. Both the first and the second step require an input of energy to break the attracting forces between the molecules. Lastly, the solvent molecules mix with the solute molecules. This process can be exothermic or endothermic. Students, when a solute dissolves in a solvent, what happens to the solute particles? Where do they go? Also, please name the 3 types of interactions that affect the tendency of solute and solvent particles to mix.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, everyone. I'm sure you had no trouble answering these questions. When a solute dissolves in a solvent, the solute particles disperse throughout the solvent. The solute particles occupy positions that were previously held by solvent molecules. The three types of interactions that affect the tendency of particles to mix are solvent-solvent interaction, solute-solute interaction, and solvent-solute interaction. Great work, everyone. Let us discuss solubility and solutions of liquids in liquids. Solubility is a measure of how much solute will dissolve in a solvent at a specific temperature. The like dissolves like principle is something we can use to predict the solubility of a substance in a given solvent. The like dissolves like principle states that if there are two substances that have similar intermolecular forces and are of a similar magnitude, then they are likely to be soluble with one another. Let us look at the example of a solution of benzene and carbon tetrachloride. Both of these substances are non-polar. They both experience weak London forces, which are forces of attraction between atoms and molecules. Therefore, when these two substances mix, they readily dissolve. If two substances are completely soluble in each other in all proportions, they are said to be miscible. Water is the most prominent solvent. This is because it is common and it dissolves a large number of ionic and polar substances. Water molecules are strongly associated with each other through hydrogen bonding. Compounds that form hydrogen bond, such as certain alcohols, tend to be soluble in water. Let us move on and discuss solutions of solids in liquids. Solids that are made up of polar molecules or ions are not soluble in non-polar solvents. The interaction between the polar solid and the non-polar liquid is weak compared to the interaction within the solid. Therefore, the solute and the solvent particles do not mix. For example, sugar, which has molecules that are lightly bound together by hydrogen bonding, is not soluble in solvents like oil. Sugar does dissolve in water, though. Students, why does sugar dissolve in water, but not in oil?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Were you able to explain why sugar dissolves in water but not in oil? Sugar dissolves in water because the water molecules attract the sugar molecules in the same way that the sugar molecules attract each other. Both of these substances are polar. The sugar does not dissolve in the oil because the sugar is polar while the oil is nonpolar. The interaction between these two substances is weaker than the interaction within sugar. Solids containing crystals held together by London forces can dissolve somewhat in non-polar solvents. However, they do not dissolve in polar solvents. For the same reason, non-polar liquids do not dissolve in polar solvents. Water, as well as other polar molecules, is attracted to ions. The electrostatic attraction between an ion and a molecule with a dipole is called an ion-dipole attraction. These are important in the dissolution of ionic compounds in water. When ionic compounds dissolve in water, the ions in the solid separate because they are surrounded by water molecules. The water molecules penetrate the compounds and surround the individual components. This reduces the strong interionic forces that bind the ions together. This allows them to move into the solution as hydrated ions. Thus, when a solute particle becomes surrounded by solvent molecules, we say that it is solvated. When the solvent is water, we call the process hydration. This image shows a potassium chloride molecule being solvated or hydrated. Today, we learned about liquid solutions and interparticle forces of attractions. We learned about the like dissolves like principle, and we discussed how this can be used to predict relative forces of attraction. And this brings us to the end of our lesson. Until next time, thank you, teacher. Thank you, students.